Hello everyone. My name is Deepesh Gujarathi and I am a systems architect at KPIT and I run the hydrogen fuel cell program in this organization. Amongst the variety of applications, hydrogen as a fuel lends itself really well to two applications. One is stationary power, that is power that is used in the grid, and the other one is for automotive applications. These are the two applications where hydrogen lends itself very well to be used as a fuel. For stationary applications, one particular class of fuel cells, that is the solid oxide fuel cells, SOFC for short, is a very promising candidate to be used for stationary power generation. The primary reason being you could give it any kind of a hydrocarbon based fuel as an input. The SOFC has an onboard reformer which converts the hydrocarbon based fuel, something like, for example, CNG, compressed natural gas, or LPG for that matter. It takes any of these fuels and the onboard reformer converts it into hydrogen, which the fuel cell, the solid oxide fuel cell, further converts it into electrical power. The input source to the SOFC, that is the CNG or LPG, could very well come from source like bio-waste, and hence that further makes this whole proposition a much cleaner alternative. Practically every large automotive OEM is involved in development of a fuel cell based vehicle today. If hydrogen is to be used as a fuel in the automotive application, there are two approaches one can take. The first is hydrogen fuel injection, and the second one is by means of a hydrogen fuel cell. Hydrogen fuel injection is one where hydrogen in gaseous form is introduced inside an already existing IC engine where it burns along with any other traditional gasoline fuel. The second approach is where hydrogen is provided as an input to a hydrogen fuel cell, and the fuel cell converts the chemical energy inside the hydrogen gas into electrical energy. This electrical energy can further be used to propel an automobile. Now, comparing the two approaches of using hydrogen as a fuel in automotive applications, in the hydrogen fuel injection system, one can expect a 50% decrease in emissions. The second advantage is about 10% or thereabouts improvement in fuel economy. However, the fuel cell seems to be a much sensible approach in using hydrogen as a fuel in automotive applications, mainly due to its efficiencies being in the range of 50 to 60%. Secondly, a hydrogen fuel cell can very well supplement an electric powertrain. Thus, the hydrogen fuel injection approach for automotive applications seems very impractical right now. Now, let's talk about the barriers that prevent mass adoption of hydrogen fuel cell vehicles today. There are three barriers. A, lack of infrastructure for dispensing hydrogen fuel. Secondly, the transport and storage of hydrogen is a big problem, because hydrogen having a very low volumetric density, it requires tremendous amount of space to store it. Thirdly, the capital cost of building a hydrogen fuel cell vehicle today is prohibited. Now that we've mentioned all the barriers to mass adoption of hydrogen fuel cell vehicles, let's talk about the opportunities for innovation. For the purpose of KPIT Sparkle, I urge you all to apply your minds and come up with innovative solutions to address the following opportunities. Since an automotive environment is a very space constrained one, the performance of a fuel cell is very important. The performance of a fuel cell is measured in terms of amps per centimeter square, which is a measure of its current density that a fuel cell can provide. We really need to achieve very high current densities where we can be at par with the diesel as a fuel in comparison today. Since hydrogen has a very low volumetric density, it requires tremendous amount of space to carry. And again, for automotive use, we need to come up with better methods and better materials to carry hydrogen safely on board a vehicle. If the hydrogen fuel cell vehicle has to be successful in India, the Indian context has its own challenges. We will have to come up with very cost-effective manufacturing processes and materials that build a hydrogen fuel cell so that it can be widely adopted in a country like India. Hydrogen has a very high specific energy number, which means if you are carrying hydrogen gas on board, one needs to pay a lot of attention towards passenger and vehicle safety. I urge you to look at the safety aspect in great detail. One of the opportunities I see is that of a cost-effective and efficient way of detecting a hydrogen leak inside the vehicle cabin. In my opinion, the biggest impact on hydrogen fuel cell is going to come from innovations on the material science side, specifically in the following areas. Since the environment inside a fuel cell is very acidic, there's a lot of work to be done on development of cost-effective and durable anti-corrosion coatings. Conventionally, the catalyst material of choice for fuel cell manufacturers has been platinum. Since we know platinum is a rare earth material and very expensive, we need to come up with non-platinum based materials which can work as good catalysts. There is a strong need to come up with alternative proton conducting materials similar to Naphion. The MEA inside a hydrogen fuel cell has a lot of carbon content in various forms. One of the primary ones being the gas diffusion layer. So I urge you to look at high performance gas diffusion media based on carbon and similar materials. Hydrogen fuel cell is a truly multidisciplinary problem to be solved, involving chemistry, involving mechanical engineering, electrical engineering, nanomaterials, material science, thermodynamics, etc. It will truly take a lot of good engineering and scientific talent along with help of industry and academia to make this a success. So if you are a good engineer, scientist, or from the academia or research, I urge you all to come up with your innovations. And at KPIT Sparkle, we provide the right platform where your ideas would be evaluated, and if there is truly some potential found in your ideas, we have the willingness, intention and the resources to take it to a really good level. Good luck.